single wavelength to determine how close we are to the theoretical prediction. So this is the theoretical prediction at 100% hydrogen. This is what we have obtained so far for 4% hydrogen. It appears that we are going to have a maximum in this region here. We are trying to get additional points. So we are obtaining the optimum thickness experimentally. We have the same shape. We have some difference in the optimum thickness at this wavelength relative to the theoretical prediction. We haven't yet obtained the thickness in our setup. This thickness is that which was measured by the monitor in the sputtering system, but we have to double check that and see what our SPR reflectance curve gives for the thickness and optical constants. We also are using optical constants for the same optical constants for the literature, even though our thickness is different, so we cannot use, in fact, rigorously, the optical constants are not going to be the same as those reported by Rotkin and Rubin. We have to do that and recalibrate this curve, but at least we have a shape that resembles the theoretical one. So in conclusion, we have determined that palladium is a better solution, at least in the simple Crashman configuration that uses a single layers with no additional chemistry on the surface. So palladium would be a better solution than gold palladium. We obtain optimum design parameters for detecting H2 in this Crashman configuration. And in future work, we intend to solve and to characterize better the stability of the surface, to see what's the typical lifetime, let's say, of the surface. How long does it take until you lose about 50% of sensitivity? We also have recent results showing that the addition of siloxane underlayer prior to the palladium layer, and if you put something like between 10 and 100 nanometers of, let's say, 5 and 100 nanometers of palladium, you start forming beads, let's say spherical beads, and as these beads get absorbed with hydrogen, their radius increase and they start touching each other, and the conductivity increases. So a very sensitive electronic sensor has been developed recently based on this phenomenon, and it is possible that the same high increase in sensitivity may occur if we prepare the surface in the same way and do it optically. So we are going to look into that possibility of siloxane on the layers, or even using alloys to see if a better sensitivity device can be obtained. And finally, once we have obtained a better solution, we will attempt to implement a sensor head integrated to an optical fiber for remote sensing, and to try to achieve the sensitivity requirements for the electric sector for transformer oil, for developing a sensor system for detecting a failure on high voltage transformers in the electric sector. So I'd like to end this by acknowledging, by thanking these agencies that provided support for this work. Thank you.